Good afternoon, good day, everyone. We are now flashing or showing the on the screen the circuit construction kit AC, which is another Phet simulator that we will use for our performance task number 3. And not only that, we can also use this simulator whenever we want to analyze also other circuit devices. But for this afternoon or for today, we will have the capacitor. So we will try to apply in our circuit only capacitors. Now we will be setting up one probably a circuit that is either parallel or series connected. And to aid that in that area now is this construction kit AC. Now after opening up the link, so the link is already attached on our here now on our link is being placed already on the URL and and therefore now we will simply open this one. So we have your RLC. So RLC actually represents the resistor, the inductor for L, and C for our capacitor. But for today, we will simply use our capacitor. So this is a picture of a capacitor, and we take it here on this side. So on this side, we have several types of uh, electrical equipments or electrical materials that we can use. So maybe one of the things that we'll be using is we will need a battery. So this is a picture of a battery. We can actually twist the battery by pointing the finger there at the top, so you can actually rotate it. But if you drag it somewhere in the middle, so you will not be able to turn the battery. Now you could have as many batteries as you would need, and you can actually connect them in a manner that is probably considered as series connection. So therefore you can actually rotate this as well. So that's our battery. Now whenever we see that or we click this end here that are being connected, and you see a scissor, you can actually detach them whenever we are already whenever we connected them already. Now we will get a capacitor here so we can get as many capacitors. Maybe in this case we will need something like 3, and we can set it up either a series or parallel connection. So aside from the battery, the capacitor, we also have some meter devices that allows us to measure voltages or current. So this one is a voltmeter. So we can actually get only 2. So we notice that if you remove 2 of that, so nothing is left there. So we can only use 2 voltmeters. So we can take it here. Now another one is an ammeter. An ammeter measures current. So what is shown there is the amount of the current. Now in our case, maybe we will not actually need an ammeter for now. What we will probably need is merely the voltage on this end and some some capacitors in our circuit. Okay, so we can also add a switch. So there's also a tool or a component there which we call as a switch. So we can turn this on and off maybe by clicking this. Now sometimes when we turn on the switch, we call it as closed, and when we turn it off or we open it, so the charge now cannot flow in our circuit, so we call it open. So sometimes we also call it as an open circuit when it is turned off, or when we close it or when we turn it on, when we allow current to or charges to flow, then we have a closed circuit or a closed switch. Okay, now another thing that we will probably need is some lengths of wire. So here is our wire, and again, just like our battery, we can connect it at the ends. Now, if we have this one, maybe we have 2 batteries connected in series, and then you can actually lengthen the wire. and maybe connect another one here and be able to connect this one. No? We could have this one as well. No? Connect it to the second capacitor. Third capacitor is connected, and eventually now we could connect the third now back to the battery. No? So we can lengthen the wire simply and be able to complete our circuit. No? So therefore you can now align this. No? Maybe let's try and cut this. No? So maybe we can attach a switch, no, somewhere here, so that at least now you'll be able to see, no, that when it is turned off, no, we can do something in our battery. Now, what happens is that our capacitors now are charged, no, so somehow, no, you'll notice that they are charged, no. So if you bring a voltmeter here, no, it's going to register some kind of a voltage there, no. Okay, so there's a voltage that is being shown. Now you notice that the sign is negative. Probably we place the terminals of our voltmeter now incorrectly. So maybe that's the correct way. No? So this is the positive end of the capacitor, and that's the negative end of the capacitor. So that's why it shows now a voltage. No? Now if we will have something like a bulb, no, if we will try to connect a bulb in our circuit here, so I think the bulb will kind of light up, no. So we'll just detach this, no. So let's just use this now for a while so that we will be able to discharge our capacitor, no. So we will try to discharge our capacitor by connecting a bulb, no. So the bulb lights up until the whole of the capacitors are completely discharged, no. So nothing is left. So there are a few voltage there, and eventually now it all runs out completely. Nah? So now the capacitors are fully discharged, and therefore now we can now disconnect it. Nah? Since we are through the discharging the device. Now, so let's just return this one. Okay, we'll return the battery there. Now, and now since we turn this off, no, so I think we are now ready to maybe now attach a wire here. No? Okay, so somehow now this is how we connect our circuit. Na? Now going back, now, if we will try to click this button here, now, so I think now if we will click this, now you'll see the amount of the capacitor, and probably now we can click the capacitor, the first capacitor there, and have the chance to change its value. No? So our maximum capacitor can only have 0.2 farad, no? 0.2 farad, and as low as 0.05. No? So again, no, in this case, you can vary, no, your capacitor. So you can click the capacitor that you have and then change its value. No, so you are able to have you are able to change its value. No, now for your case, no, so you can adapt any value of your capacitor. And however, no, your battery as well, you can click the battery and be able to change its voltage. No. Now, the maximum voltage that you could attain is 120 volts and as low as 0 volts. No? So if it's 0, of course, the whole battery here will only provide 9 volts. No? Okay. So again, you can change each of these batteries. So if you connect them in series, then maybe now you can have a total voltage there. No? That is now the sum of the two. No? Since you connect them in series. No? So you can have that in steps by clicking this, no, little by little. So if you want a better value, no, than simply sliding it, no, so you could attain a much more exact value, no. So by clicking the buttons, no, so you could have a better value. Now, if you want to use only one, then you can do so, no. Anyway, the value can go as high as 120 volts, no. So here, if you have two of this, then that's a total of 18 volts, no, because you're simply adding the voltage plus the three capacitors that you have now, which you connect in series, no. So you can apply your principle there, no, in determining the total capacitance if you want, no. And then of course now when we switch this on, we will not switch that on because the capacitor will eventually, no, get full, no. And I think, you know, the other value that you are able to get now is the voltage in each capacitance, no. So you can get the voltage, no. You can have the capacitance value. The capacitance value are fixed, no. And maybe, you know, you can use the equation that you know by multiplying C and V together to get the charge that is present in this particular capacitance, no, or capacitor, no. So multiply the capacitance value times the voltage there, then you'll be able to get, no, the charge that is stored, no. Now you noticed a while ago that the charges are indicated, no, by some plus sign, no. So this is how we set up our, no, our series connection. And if you want a parallel connection, then we have to change the circuit that we have, no. Now we will not need the ammeter here, no. We don't need that. We will only need the voltage and maybe, no, the values that are set, no, in our, no, battery, no. So you can call the total here as the V sub T value. That's the total voltage, no. And then maybe, no, you can use our equation to find the total capacitance, no. Or maybe, no, since you could measure the voltage in each, no, capacitor, then you can get the charge as well, no, by using your equation. Q, no, is equals to C times V, no. So if you know V, you know the value of capacitance, then you can simply multiply, no. Now let me change this, no, and I'm going to cut this one and I'm going to set up a parallel connection, no. So give me a moment, no. Okay, what we did now, we simply detach, no, each capacitors. And of course, now you have to name maybe, no, or label each of these capacitors. Maybe the first one is C sub 1 or capacitor 1. The next one is capacitor 2. The third one is your capacitor 3. Now, again, you can use the scissor there now when they're attached, and then you can click the scissor to detach each of these devices. No? So once they're detached, we are now ready to move them and form a parallel connection. No? So maybe now we will have to set it up like this, no, to be able to achieve, no, parallel connection. No? So we will have same values of capacitances, no? But maybe now set up a parallel connection this time. No? So let's have this one. No? And perhaps now we will also need, no, maybe this one still, so that we'll be able to link, no, the top part. No? So that's one. No? And then maybe we need another wire. No? We attach this and connect this second, no, capacitor. Get another wire and connect the next, no, the next capacitor. So we have now 3 capacitors that are connected at the top. No? Next, we need this now to be connected below. So maybe at the joints, now you have the ability to adjust, no, the lengths of the wire. No? So you need to point the pointer here, no, at the corner, so that you'll be able to adjust the alignment. No? We need some more wires, maybe here. Now we could not connect it. We could not connect this one, here, so maybe we'll need to detach it. No? We need additional wires here so that we'll be able to complete it. Now here is one. Now we need another wire for this one, no? And maybe two more, no? So we connect this one. So we are now able to complete that, no? Again, now the thing is, when you want to energize the circuit now, you can turn on the switch, no? Again, now I'm not turning it on because you'll notice that the capacitor will eventually get fully charged, no? And that will happen very, very fast, no? So this one, no? So we have an 18-volt source. When we turn it on, no? So this one now gets fully charged, no? So, but this one now is an example of parallel connection, no? So at the top, no, similar to, since this side is attached to the positive side, so most likely that's the positive end of the plate also, no? So the top, no? Now the red colored lead, no, of the voltmeter, we call it as a voltmeter, the one that measures voltage. So the red one is the positive lead, no, or the positive terminal of the voltmeter, no. Now the black one is your common side or your negative side, no. And therefore now you'll see here that the reading of the voltage can be found now here, no? So again, if you want to get the charge here, so you can have the amount of the capacitance, no, 0.11, and multiply it by the reading, no, of the voltmeter, no. So maybe in each of these capacitances, you can get your voltmeter to measure the capacitances. That all that you have to do is to simply transfer, no, this prong or this terminal, no, or lead, no, to the ends of your, no, of your capacitor, no. So that's how the voltmeter works, no. And again, on this end is your, of course, your battery, no. So you can set up one series connection, no, maybe 3 capacitors that you connect in series, or you could have this parallel connection of our circuit, no, as shown here, no. So again, this is our circuit construction kit AC, no. And what you will use is the RLC, no, option, no, or choice, no. So when you perform this one, no. So what are the devices again that you need? You need a battery, no, maybe one, no, or maybe only one is enough, and some wires, no, maybe a lot of the wires. You can simply click and drag it, no, from this end. Now, if you are done using them, you can just click them from this side and place them back, no. Now you will need a capacitor. So this is our capacitor, no. They are symbolized by these two parallel plates, no. And again, now we can change them by simply clicking, no. The capacitance value is changed by simply clicking the capacitor and sliding this button, no. Now the same is true for our battery. So we can also change the value of our battery, no. Okay, so I think, no, that's the one that we will be introducing for today, no. So the voltmeter and the circuit that allows us to set up series and parallel connected capacitances, no. So I hope that one is you find that helpful, no?